Okay, this is the notes for Unit 3, Lesson 3. On this one, it's our learning target is I can evaluate a function. I'd say on this one, do not overthink what it's asking you to do. You've done stuff like this before, where you have evaluated, where you plug a number in and evaluate what the value of y is at when x is 7 or when x is 12 or whatever it is. So plug a number in, simplify, and that's pretty much what we're doing today. So recall from Unit 1, when you evaluate the expression, when I say evaluate this expression for x equals 10, that meant plug 10 in. So take x out. So x is gone, I'm going to put 10 in its place. Okay, and then evaluate. So order of operations says to multiply first, so that'd be 40 plus 2, so that's 42. Okay, something like this guy, again, take out the y, plug 16 in its place. Okay, order of operations would say to subtract first, so that'd be 12. 12 divided by 3 then would be 4. Okay, and over here, leave a space, take out the x, so x is gone, plug 2 into its place. So it'd be a negative 16 minus 4. Order of operations says multiply first, then subtract, so that'd be a negative 20. Okay, and all this is a function. These expressions were functions that you plugged numbers in for. So a function rule is an expression that represents or describes a function. So these were rules telling me what to do. This said whatever x was, quadruple it, and then add 2. So when x was 10, I quadrupled that, got 40, and then added 2. This one said subtract 4 and then divide by 3. That's what the rule is. Okay. So writing equations in function notation. This is simply notation. It's I think the most confusing part is people overthink, and they think that things mean things they don't. They go too far with it. So to write an equation in function notation, the only thing you need to do is change the y to, and we say f of x. So when it says f with an x in parentheses, we say f of x. The f is not a variable. You're not solving for f. Okay, it represents the name. Okay, we just use f most of the time because f for function. They could put g of x. We could put g of x, s of x, v of x. We can name it any letter we want. It's typically we start with f. Okay, we typically use f. So to write these in function notation, I would put f of x equals 3x minus 2, and that's it. That's the same thing in function notation. The rule is triple it and then subtract 2. That's all it's telling us to do. Okay, over here, f of x equals negative 4x plus 6. Okay, so function notation, that's it. Take out y, put f of x in its place. F is the name, and that's it. Okay, so when you evaluate a function, you will see f of x be replaced by something like f of 2. We say f of 2. That simply means you need to replace x with the number, in this case 2, in the function rule. Okay, kind of like up here, it says replace the x with 10. Well, I would do that by saying f of 10. Okay, so f of 10 equals. And that says plug 10 in, see what it equals. So f of 10 equals 42. Over here, this would be f of 16. So f of 16 equals 4. Okay, and so on. So down here, if this is f of x, this rule, this says plug in negative 2. So f of negative 2 says plug in negative 2. So I got negative 5, plug in negative 2, and see what you get. I'm only doing this part, okay? So I'm evaluating this part, not that, okay? So this would be 10 plus 5. I'm sorry, that's a 2, 25. 10 plus 25 is 35. So f of negative 2 equals 35, and that's your answer. That's where you stop, okay? Stop. Because that's your answer, okay? Over here, this says plug in 10. So f of 10, says to take out x and put 10 in its place. So this would be 100 minus 4, which is 96. So f of 10 equals 96. Stop. Stop right there. That's your answer, 96. Okay. We don't divide by 10 to solve for f because f's not a variable. It's just a name. It's a name for the rule. Told us which rule to use. So down here, here's the reason why we have names. Here's two different functions. Okay, two different rules. We have to name them so we can tell them apart. Same reason we have different names so we can tell each other apart. Okay, so this, what is f of 8 plus g of 3? Well, I'm going to figure out what f of 8 is first. That'd be negative. So I'm going to do the opposite of a number, plus 2. Well, plug in 8. Okay, and then plus, and g of x would be 3. I'm going to plug 3 in its place. Okay, so this would be negative 8 plus 2 plus 9 plus 4. Because this is the plus, I'm doing them separate right now. Okay, so I got this would be negative 6 plus, and then 9 plus 4 is 13. And now that I have numbers, now add them together to get 7. Okay, so I figured out what f of 8 was negative 6, g of 3 was 13. Now add them together. Okay, so I want you guys to try number 4. So complete on your own. So complete that on your own. Maybe pause the video and do that right now. Okay, so evaluate the function rule to find the range of the function given the domain. So if this is the domain, so in other words, I have given you 3 x values, and I'm asking you to give me 3 y values. So if I give you a domain and I want to know the range, that means I've given you inputs and I want to know what the outputs are. Okay, so if this is negative 4, I want to know what f of negative 4 is. 0, I want to know what f of 0 is. Whoops. And f of 3. So I want to know what those are. So equals, equals, equals. So I've got the absolute value of 2 times negative 4 minus 15. The absolute value of 2 times 0 minus 15. And the absolute value of 2 times 3 minus 15. So this would be a negative 8. So the absolute value of negative 8 minus 15. But the absolute value of negative 8 is 8. So 8 minus 15 would be negative 7. 2 times 0 is 0. The absolute value of 0 is 0. So that'd be negative 15. And then this is 6. The absolute value of 6 is 6. 6 minus 15 would be negative 9. So if the domain was negative 4, 0, and 3, the range would be negative 7, negative 15, and negative 9. Okay? So now you try this guy. So this one is going to take a little bit longer. Let's see. I'll do this guy here. So if I'm plugging in negative 6, 3, and 9, that means I got to take f of negative 6, f of 3, and f of 9. Okay, so I'm going to plug in the values, and I'm trying to find the range if this is the domain. I'm going to do the same thing over here. I may just skip that and have you guys do that and have you try it. Yeah, so I've got, and again, make this f of x. Okay, so f of x equals, so I got 3 halves times negative 6 over 1 plus 1. Okay, do some reducing here, so this would be negative 3, so 3 times negative 3 is negative 9 plus 1 is negative 8. This one I got 3 halves times 3 over 1 plus 1. Now this would be, for multiplying, so it would be 9 halves. So 9 halves, and then 1, how many halves equals 1? It'd be 2 halves, so that's 11 halves. And then 9, I got 3 halves times 9 plus 1. So this would be 27 halves plus, How many halves equals 1? It'd be 2 halves. So that'd be 29 halves. 29, don't write them backwards. 29 halves, okay? So try this one out. Try the same thing on that one. We'll check those. And then at the bottom here, when it says complete the table, it's the same thing we just did, and it's basically 5 problems in one. So you just did it 3 times. Now we need to do it 5 times down here, okay? So you'd have to plug in -4, subtract 3. So half of -4 would be -2. -2 minus 3 is -5. Plug in -2. Half of -2 is -1. Minus 3 is -4. Plug in a 0. So 0 minus 3 would be -3. If I plug in a 2, half of 2 is 1. 1 minus 3 would be -2. Now plug in a 4. Well, half of 4 is 2. 2 minus 3 is -1. Okay? So I want you guys to finish these. Really, you guys have got to do some of this on your own and make sure you know what you're doing before we head into homework. So don't come in with these blank. So finish these. You got a lot to do, so finish and finish. Okay, so do those for credit. Those aren't done. I do not give you credit for those notes. Okay, you did a lot of work. You might as well finish those and see if you know what you're doing.